that my slides aren't pretty and I'm looking at you, so it's a little bit awkward, but I'll do my best on this. But I was a teacher for 14 years. I taught grades 4 through 7 mostly, and then I did spend 1 year teaching ninth grade remedial math. But I spent a lot of years in Title One, and in America, Title One is we work with kids in high poverty schools, and I worked with a bunch of reading specialists who did not want to teach math. And so I kind of became the math interventionist at an elementary school. And that started me on this quest of why do kids struggle in math? When I did the same intervention with 6 kids, 3 of them would get better and 3 of them would still struggle. So that kind of started me on this 30-year journey of learning all I could about why kids struggle in math, never dreaming that would become my leadership niche. As I progressed in my career, I went to Boise District Office as a federal programs consultant and helped a lot of other schools develop intervention programs in both math and reading. Then I went to Nampa, where I raised my family, and I opened a high school as an assistant principal. But I discovered that being a building administrator was not my calling. I loved teaching teachers. So I went back and got my doctorate in math education. I did my dissertation on math intervention, and I taught at Northwest Nazarene University for 8 years. And then I also learned that my heart really was in K-12 public education, which I'm from an immigrant family. So my family, public education was really how my family has become who they are in America as educated people. And so I went back to public education as the administrator of curriculum and assessment in a small rural district here in Idaho. And then that led me to going to the State Department of Education in Idaho as the mathematics coordinator. So this job's kind of put together my love for teaching teachers, my love for kids who struggle in math. What I've learned is that math leadership is a niche. There's a whole, there's really a circle, a community of about 200 people, I'm going to say, on a national community of people who are really advocating for strong math education in America. And I get the fun of being the maths cheerleader in the state of Idaho. I do want to emphasize that today I am representing myself. I'm not representing the superintendent of public instruction, which is the elected official that I work for. I'm simply here as Mike's former colleague. So I will be giving you my personal email address is I put right there on the slide. If you ever have a question about math or want to talk more about it, it's always my favorite subject to talk about. So a lot of you put in the chat already who you are and where you're joining us from. But I wanted to just point out whenever you see this little let's chat, it's a time for you to sort of think about what I call chunk and chew. When I give you a whole bunch of information and have you talk about it. I will say that talking for 40 minutes is not my preferred mode of instruction. So this is really awkward to have it be a one-way conversation. So I'm going to use the chat as a way of getting some discussion, but we'll do the best we can with this big of an audience. So here's my learning targets for today. I know it looks like a lot, but we're going to cruise through them. But I really want to equip you to talk about differentiating instruction in the math classroom. And in order to do that, we need to talk about the definition of mathematics for you and why it's important that kids have a strong math foundation. I want to talk to you a little bit about how our brain processes math and why those 3 kids struggled and the other 3 didn't after some intervention. And then universal design of learning is a concept we'll talk about, and then I'll get into 10 strategies. And that's a lot for 40 minutes, so we'll kind of be clipping through those. But along the way, I'm going to share some resources that you can use, whether you're in your a classroom teacher or as a leader. So before I get into anything about theory, let's do a little bit of math. So that may not look like math to you, but it is in today's world. So we won't do this. This would normally be a class discussion. So I'm going to be doing a very adapted version, but so you're kind of going to just be doing this on a piece of paper with yourself. But what do you think that graph could be about? What do you notice and what do you wonder? If you want to put some thoughts in the chat, you can. So how does that label on the x-axis change your thoughts about the graph? So do you think, what could it be about? Ups and downs, it could be about income. So, number of years since being founded implies that maybe it's about some companies. So do you think they were all founded at the same time? So there is absolutely no symbols on the slide you're looking at, but you are doing math. This is mathematics, because mathematics is about representing the world in visual forms. So now what? So Mike was right that he said it was about income, which we would call revenue. So now we've defined the y-axis with the label. So we've got number of years being founded and annual revenue since being founded. So what do you think it could be about now? Is that chain? How many of you had that in your head? Okay, so that raises then some more questions. What do you notice? What do you wonder? Why is Facebook line look different? What does it mean? What does the shape of that line mean? So some questions we could ask kids if we put some numbers at that. Are these lines, are they a linear relationship? Is it progressing in a linear way or is it progressing exponentially? And what is the difference between the shape of a line that's linear and the shape of a line that's exponential? Could we make an equation that might predict what Facebook would be making in 5 years? Could we use this data to predict how long it might take Blue Sky, a new social media app, to reach 5 billion in revenue? Can we all find a way to maybe open a social media company that would help us make 5 billion? So another thing you can have kids do is what would be a headline that could go with that graph? And then did the headlines they create match the headline that was actually in the news? So this is data that is actually from a source. And this resource is called Slow Reveal Graphs. And they are all graphs about real world issues in our world today. It's a great resource for really 3rd grade through 12th about topics that are interesting to students. So you can take that news article and this is a great lesson to introduce the difference between linear and exponential functions in a high school class. But there's also lots of things that you can do in lower grades, like the shape of the data, which is like more of a middle school concept. So a good math lesson actually can be expanded. We call them low floor and high ceiling, that you can work a context anywhere from 3rd to 12th grade, depending on the math content that you attach to that context. So when you think about math, is that the kind of math that you've been thinking, that you'd think about when you think about your own math education? So put into the chat, you can use an emoji or a word. When you think about math, what word comes to mind or what emoji face?
Almira, that's what I think of too when I think about math. There's the tear.
I wasn't sure if that was sweat, blood, sweat, and tears is how I'm interpreting
Oh,
that one.
that might be sweat. Yeah, that works too.
So we have some math lovers application. Needed skills. So, and I don't know if this is an American sensation or if it's international, but a lot of people in America have very negative associations with math. A lot of parents tell their kids, I wasn't a math person. It's okay for you to not be a math person. But all of that comes down to how do you define mathematics? And it actually is kind of interesting. Other countries do tend to define mathematics in a more problem-solving approach compared to an arithmetic approach. So if we only think of math as like 1950s shopkeeper arithmetic, addition, subtraction, multiplication, division, which is still how a lot of policymakers define mathematics, But math today is about creativity and curiosity and problem solving and coming into a situation where you don't know how to represent it and you have to come up with a way to represent it with symbols so that a computer can make a model. That's the mathematics that's used in the real world today. So we need students who have some joy, wonder, and curiosity. And from all of your emojis, a lot of you have that. And maybe those of you who don't feel that way about mathematics might have been a little shyer putting your emojis in. But a lot of students are only being taught math in a very rote arithmetic procedural way. And they aren't experiencing math as this curiosity producing subject. But we really want students to leave K-12 with a strong math identity so that they can go on to graduate for all their hopes and dreams. So think about what's your vision for your students after they cross that stage. We all want our kids to be prepared for the world today, but the world today, everywhere, requires STEM. The language of STEM is the M. So they're one of the most fastest growing high school after school athletics activities is esports at the college level and in high schools. And this is international. We have all these kids that absolutely love STEM. They love science. They love making things. They love taking things apart. But what's happening in America, and I don't know if this is true internationally, when they hit that high school level math, they start realizing how it's hard. And so they drop out. So they don't have a work ethic to persevere through problems that they don't know the answers to. And our kids today, everything is in these short sound bites. But mathematics takes a lot of perseverance over time to become good at it. So it's normal to not be good at math. And you become good by having a growth mindset versus a fixed mindset. There's no such thing as a math person versus not a math person. Math people are made, they're not born that way. So it takes practice and perseverance over time. We say it takes 10,000 hours to be good at something, and that's how long it takes to be good at math. But a lot of students are dropping out of their STEM degrees because they can't persevere past that struggle part of the math. The mathematics as a subject itself is about productive struggle. So it's kind of a tough thing to try to get the kids through. Then the first thing you have to overcome when you're working with kids to struggle is redefining math for them. The math is not just about memorizing and procedures. It is about interpreting the world and representing the world, and it's very, very related to STEM. So what we know in America, and I don't know if this is true in your countries, but that you're working with, but less than half of our high school students are graduating ready for college and careers for the mathematics they need. 40% of them are below basic in math. Now, I'm not sure what's going to be happening with the National Assessment for Educational Progress in our country right now. So this is some data that may not be available in the future, but this is what we know now about our graduating seniors. So the change in math in our world, we used to use math as sort of a way of filtering out the most talented students so that we could send them to NASA to become astronauts in America. And that started around like the Sputnik age and the race to the moon. And that's when we implemented the calculus curriculum at the high school level. But in today's world, we need math to be more like a pump than a filter. We need to be pumping kids into the workforce who are a variety of math. Math is really expanded as a subject. And so they don't just need calculus anymore. They need things like statistics and data science and applied math at the high school level. So there's a lot of different math paths you can create in your high school system to help kids be ready for a STEM world. So I'm wondering, in the role you're in, what is your biggest challenge related to mathematics from your role? So if you could tell me your role, your location, and the challenge. Go ahead and put that in the chat. And this might be an interesting time for Ray and Jacob to jump in about what are the things that you see in your network as the struggles people are having in math.
I think one thing you said, Cathy, that I think we run against regularly is statistics. We deal a lot with statistical analysis of things, and that's one thing you typically don't think about when you think about math.
And one thing that I've noticed Kathy, is that I don't notice the same attitude that I've seen in the United States because I know exactly what you're talking about, where parents and even some teachers, like English teachers, saying math is just not my thing, and I just am not good at math, or let the math teachers deal with that. I don't know if I hear that as much or feel like there's that same attitude with international schools that I've gone to. And I think there's a little bit more encouragement to just tackling and having that growth mindset and being able to jump in and saying, okay, let's do this. I think with some of the comments that there's a lack of motivation, but it's not necessarily towards mathematics. It's just kids being kids and just not being motivated. But I think it's important to help change that mindset with parents. I know that's what I've worked on in my schools in the United States and with the schools that I've worked with internationally is let's change that mindset from the parents, administration, teachers, that anyone and everyone can do math and it's exciting to do it and there's beauty behind it and there's a good quality in being able to finish a math problem and build some confidence that way.
And
And I think another thing that we have to take a look at as instructors is that we, and I put it in the chat earlier, it takes support from their instructors. And in the United States, at least, too often, math teachers are not like Dr. Cathy. They are not personable necessarily. They love their subject, but if you don't get it tough, we're going to move on, rather than taking a look at, what do we do to support our students to make sure that they understand and are able to move on themselves.
Yeah, and one thing that kind of crossed my mind, which sometimes that's good and sometimes it's not good. What if we change the title? We don't call it mathematics. Let's find another word. And because I think you're right, a lot of kids are scared by the title. And what if we just change the title to basket weaving or something like that? That really is something totally different.
well, that's interesting you say that because in Idaho, we are working on getting data science into high schools, kind of a junior level course. Data science is actually a great way to sort of entice kids into pre-calculus. And I do think that you do have some cultural differences in whatever country you're in that how much they value mathematics and advanced mathematics at the high school level. I'm from a very rural state, and a lot of rural communities, they just don't see the point of taking pre-calculus and calculus because they don't understand the STEM world of opportunity out there for kids. Whereas higher income parents and parents from certain countries, like they already have a higher value of the subject of mathematics as a subject. So the cultural circumstances surrounding what we think about math really will impact kids' motivation on learning it. But another big impact on their engagement, like you were saying, is instruction. So if you're only teaching math in a very procedural way, which is how a lot of math teachers have learned it, it's boring to the kids. And in today's world, the kids are there's so much at their fingertips that's more engaging than doing calculus equations. So we really have had to work on making math relevant and engaging and connected to the real world, and addressing some of the same challenges you are. We don't have it all figured out, but we do have some amazing community of people really trying to work on changing math instruction for all students, really K-12. So let me talk a little bit about that. Some of the reasons kids fail, and I didn't mean to have all these fly in, but sometimes they've just missed instruction or they've moved a lot. They have a parent died in fourth grade and they don't remember anything from fourth grade math, which is a huge pivotal year. They have strong organizational skills. They might have poorly designed curriculum. They don't do their homework. The instruction is ineffective that they're experiencing. If they have years of ineffective instruction, that can lead to them being 2 to 3 years below grade level. They don't have clear achievement targets. They don't know what they're trying to hit. And then we're going to talk a little bit more today about lack of differentiated instruction within the regular classroom. So what we end up doing is remove kids from grade level instruction to catch them up, but we simply don't have enough time in a school year to teach everything they missed and everything they're supposed to get for this year. So what happens is that when you take kids out of the regular classroom to remediate, they actually just end up more and more behind. And then by the time they get to the college level, they tend to drop out. of college, not just math. Another big issue is language barriers can really impact math performance. And a learning disability there are 5 to 8% of students might have a specific learning disability in mathematics. So what's hard in the math classroom is you might have a kid that's low in math, but it can be any one of these reasons. And teasing out an actual diagnosis of a why, that's really complex, and it takes a lot of background for an interventionist to work with. Other types of learning disabilities like visual spatial challenges, executive functioning, even dyslexia can also impact performance in a math classroom. So I want to talk a little bit about that difference between disability and difficulty. So a math disability is also known as dyscalculia, and about 5 to 8% of students have this. Whereas, so if you don't know that a student has a disability, we usually use the word math difficulty. So we would say this student's having a math difficulty, but I don't know why, versus a student I know has a specific learning disability in mathematics. So those are two terms that I would encourage you to use when you're talking about students who struggle in math, because like I said, 5 to 8% might have a disability, but most of the kids who struggle in math are struggling for some of those other reasons. So as we were coming out of the pandemic in America, the 3 organizations that really lead the way in the national space in America in mathematics are National Council Teachers of Mathematics, National Council Supervisors of Mathematics, and the Association of State Supervisors of Mathematics. And they really, they published a joint position statement, and they said 3 things as we are wanting to catch kids up in math would be keep them in grade level content, make sure you're using good teaching practices, and advocate that all students need grade level instruction. So those are kind of the 3 pillars around as you're thinking about helping kids that struggle. Do not take them out of their grade level instruction. They need to have grade level instruction and additional help in order for them to make progress to catch back up to their peers. I do recommend that if you're a teacher, you can join the National Council of Teachers of Mathematics in America, and there's all kinds of resources and journals and a community of support for you, free professional development. If you are a leader, I would recommend joining the National Council Supervisors of Mathematics in America, and you will have a lot of support for your math leadership journey. So when we talk about leaving kids who are struggling in the regular math classroom, we have to think about universal design of learning. And this is a story I heard a very long time ago that I've always remembered. From a man named Rick Lavoie. He wrote the books, It's So Much Work to Be Your Friend and The Motivation Breakthrough. So he told a story about a janitor who was shoveling the front of a school, similar to what's in the picture. And there was a whole bunch of kids trying to get in, and the janitor was shoveling the ramp. And one of the young students asked him, "Mister, why are you shoveling the ramp? More of us need to use the stairs." And the janitor answered the student and said, "But if I shovel the ramp, you can all get in." And that is universal design of learning. We're shoveling a ramp. It's very similar to what we do for people with physical disabilities. How many of you have ever gone up to a door and you push the button for the door to open, but you don't really need it, but you have it there? So when we think about universal design of learning, we're designing instruction in such a way that it's going to help those students who might have disabilities or limited English abilities, or in your countries, maybe they speak English and they're having to do academics in another language. We're providing enough support so that they can all enter the content. So when we talk about those equitable teaching practices, you are welcome to use this. This is straight from the book by NCTM called Principles to Actions, and it's 8 research-based teaching strategies. We have a lot of research around that we know work in the math classroom. So in Idaho, we have this card, and my goal has been every single teacher in Idaho has this card on their desk or on their wall to remind them of what good math instruction looks like. So if you are a leader working towards having a goal of what is the math instruction we want for every student in our school or our system, if you are a teacher thinking about, are you using these 8 teaching practices, and does your curriculum help you use these 8 teaching practices. So these are some teaching practices that are help with the universal design of learning because they help all students access that grade level material. So when we think about connecting representations, so we just talked about the graphs. So we started with the visual representation, which a graph is, but in younger grades, something like a tree diagram or an area model are some visual representations of multiplication or fractions. But generally, mathematics is this going back and forth between a context, a situation that we define with words, so or either oral word language or written language. And sometimes we can represent it with objects like manipulatives or pattern blocks or cubes. And then we make a visual model in some way, and then we convert that visual model to an equation. So mathematics as a subject is this going back and forth, these interrelationships between these 5 different ways of representing any kind of mathematical problem. So that is the heart of algebra. So when you are teaching in a way in 4th grade that helps kids go between the physical objects to drawing it, to representing it with a picture story, to representing it with words, and then to making an equation, you are laying the foundation for algebra. If we only teach math in a very symbolic way, like I'm teaching them addition and I'm teaching them to carry the 10 and I'm just rotely walking them through the steps of a procedure, but I'm not bringing in any visual models. I'm not bringing in any words and language. I'm not getting them to talk about the math. It's like you're developing one muscle, but you're not developing the other 4. So when they get to algebra, they fall apart because the whole idea that in an algebra problem, if you have a 2-step equation, I can start that problem in 2 different ways. That just freaks kids out because they've been so used to, they're being conditioned to just copying what the teacher does and mimicking that they can't really think about the context of the mathematics when they get into algebra and above. And that is one of the reasons that they tend to get discouraged or unmotivated or quit. So what we do in K-8 to get kids ready for Algebra 1 has a huge impact on their success in high school. So here's an example of a problem I took from an open source resource called Illustrative Math that's available for all of you if you don't have a math curriculum, that's a great one that's available for free. But here's an example of feeding a crowd. And you can see that there's a chart with symbols, but there's also a context with words. And then I made there's a visual model. This is straight from the curriculum. And then there's a graph. I actually made the graph on Excel myself. The book showed it these 2 ways, but I wanted you to also see that I can graph this relationship. This is the heart of mathematics. So in your own classroom or in the classrooms that you visit a lot of, what modality do you see math being taught the most? Symbols, language, or visual models? Could put an answer in the chat, or if anybody wants, Ray or Jacob or Mike want to respond.
Yeah, for me, I think that's a tough one because you see, it depends on the teacher, it depends on the subject area too in mathematics. But yeah, symbols, language, and visual models. I think this is good because this makes us really think about what we do see in a mathematics classroom. And depending on the grade levels too, I think that all kind of weighs into that.
I'm seeing a lot of people putting visual models in the chat, which is not typical for most of the audiences I've talked to. So there's definitely something going on in these international schools that is different than a lot of American schools. So I'm actually really excited to hear that. Maybe I should come visit. A lot of the mathematics classrooms that I walk into, we still see a lot of really traditional teaching kids how to do the procedure, but not having them think about the concepts. But visual models for me, was a huge game changer in helping kids who struggled in math. Once I learned, I'm actually going to give you a resource on how to find some visual models, but visual models are sort of that in between the context, the words or the manipulatives and the equation. And that was really changed my math instruction.
There are two things,
So
Dr. Cathy, that I've observed. I've been in hundreds of schools in that part of the world, and two things. Number one, usually when I go into a classroom, the students are having fun. It's not a drudgery. And the second thing is, I do believe that in most cases, I see schools in the Middle East and in that part of the world where students are doing better on the average in mathematics than many students here in the United States, because I think the teachers understand it can be a fun subject.
that is amazing and inspiring. And I have heard people telling me, like they teach mathematics very differently than we do in America. It is changing slowly, but it literally has been my whole career. We've been working towards this change. So I tell all the teachers in Idaho and all my former student teachers that if math is not fun, especially in K-8, you're doing something wrong. Math should be a really joyful time of day for your students. It should be promoting curiosity and wonder. There's a great book I'd recommend if you really want to get into the brain science of how the brain learns math. It's called How the Brain Learns Mathematics by David Sosa. And it kind of goes into this idea of these three gears in our brain. So when we think about math, a lot of people think of it as only the symbols, but our brains actually process math in three different parts. There's the part of our brain that visualizes an internal number line. And then there's a part of our brain that converts it to words or a story. And then there's a part of our brain then that converts that context into symbolic language. So in formal words, this is all based on DeHane's research. He's the same person that did this, that developed the science of reading theories. That we're not as far along in understanding the brain processes in math and how that converts to instruction as we are in the science of reading, but we do know some things that math doesn't just happen in one part of our brain. We have that ability to visualize magnitude, words, and symbols. So I always describe this to my students as a triangle. So like the triple code model is that you have this constant interaction between visualizing four dots, converting that to the word FOUR, and then converting that to the symbol of four. So for young children, that's that conversion between those three different ways of representing a mathematical idea, whether it's 3/4 plus 1/3, or you're talking about the number four, or you're talking about y equals mx plus b. It's this idea of I can visualize it in a model, I can describe it in a context, and I can represent it with symbols. For people who don't have the disability, they can go back and forth between those three different ways of thinking about a concept. But for people who have a disability, sometimes they can't do one of those. So they compensate by using the other two. And that's really the heart of differentiating in the math classroom. If you are teaching in a way that is constantly working those three modalities, you're going to shovel the ramp for more kids than if you're only teaching it in one way. So Jerome Bruner also has a theory that we've been using in math for a long time. We call it the CRA sequence. They now call it the concrete, semi-concrete, and abstract. But it's the idea that we start with a story. So the context I gave you about social media, that was a context that teenagers would relate to. In the early grades, we might you might have something about gummy bears, and manipulatives are also a really strong component of teaching math in the elementary grades. But then we move to that representational, and that's where visual models come in. And then we help kids then convert that to symbols. So Jerome Bruner thought of this as a sequence, but modern day brain research tells us it's more of an interaction that's happening all the time. And you can really access the concept through symbols, words, or the visual models. But over a week of instruction, you want to make sure that students are experiencing a concept in all three of those ways. And if you're doing that, you're going to have higher achievement and more engagement. So when we think about differentiation, there's some learning supports you can use that are kind of based in this theory of helping support either the visual code, the verbal code, or that symbolic code. So we're shoveling the ramp for everybody. So I'm gonna just share 10 quick strategies. I did make a handout if you open that folder. Let's see if I can get that in there. Put it in the chat one more time in case you didn't get it earlier. If you open that folder, you'll see a handout that says learning supports for the math classroom. I used to call these top 10 accommodations. I don't know if the word accommodations is a special education word outside of America, but in America, we generally associate the word accommodation with students with disabilities, and these are the things we do to help them be successful, like having a ramp instead of stairs. We have that in buildings, but I've started calling them learning supports because I've realized that these are strategies that work for all kids for any context. And so we don't really need to say they're only for students with disabilities, but that is the research where these all came from was for strategies that work for students with disabilities. But as I've tried them with more and more kids, they really work for people that are just visual learners or linguistic learners, and they're not as strong in symbols as others. So I'm going to walk through these pretty quickly. So the first one is called pre-teaching and reteaching. And this is just a simple strategy when you've got a student in your classroom who struggles with problem solving. If you just call it like when the rest of the class is working on something else, you know you're going to do a problem the next day. You call the two kids over and you say, hey, we're going to do this problem tomorrow. Let's walk through it a little bit. And they basically get a head start. And so that you can because what a lot of kids is struggle with executive functioning, they just don't know where to begin a problem. But when you've talked that through with them on day one, and then you give the problem to the whole class on day two, they go into the problem with more confidence. And you've kind of basically given them, you could give them a visual model, you could give them a strategy, and you're just giving them an extra exposure before they have to do it with a group. And then if you really want to increase the exposure for those kids on day three, you call them back and you say, okay, can you tell me what you learned from the problem solving activity yesterday? So that was where you just kind of, you give them a little bit of some people call that prime the pump. Then they do the problem with the class and then you come back and you review it. So they actually are getting 3 times the exposure of the other students in their class through 5 minutes of pre-teaching and 5 minutes of reteaching. Any kind of visual aid. So I love things like foldables. This is a multiplication quilt we used to make. We called it the cheat sheet, and everybody could use it. What happens when you give them visual aids like this hundreds chart, 2-colored counters? Kids who need them will hold on to them, but as they develop the ability to internalize that number line, they will naturally give up visual aids that you provide. Students with disabilities will not, because that is the disability, is that they cannot visualize a number line. So kids who are hanging on to those visual models, they're the kids still counting on their fingers in junior high. Those would be kids I would be having some red flags about their ability to visualize internally and to memorize, which are two big red flags of a student with a disability. So these are some great things I've used, Dynazyte foldables and Kim Sutton that just have lots of visual aids for the math classroom. And then interactive notebooks are another way. I had a student that was a high school student and really struggled with, she couldn't remember the difference between positive and negative direction on a number line. So we just started this notebook of drawings for her of things she couldn't remember in her brain visually, but she put them in the notebook and we drew them. She had that reference that other kids were relying on their brain. She had her notebook. So it's like you're kind of replacing that whatever code is a struggle for them, you're helping them make those connections in visual ways. I had a student in 6th grade who we did interactive math notebooks, and she told me she used her 6th grade notebook all the way through high school. So you're just kind of capturing those things that they need to remember for that next concept coming up. Anchor charts are another way to sort of shovel the ramp. When you can make, especially with your, like if you're teaching something like fractions and you talk about all the different models, having this up for the whole fraction unit, actually I would leave it up all year, helps kids kind of have that anchor to come back to and something they can't remember. And it's just on the wall, but they're remembering it as the visual model, not just the procedure. So visual math models are another I've talked about that quite a bit, but these are some examples of visual models, and those, like I said, help make that link between um, a word version of a math problem and the symbolic version. Drawing it or creating a visual model helps them make that bridge. A great resource for visual models is Graham Fletcher progression videos. So when you get ready to teach fractions, for example, you're going to have these slides. You take that link at the bottom of the slide. He will walk you through all of the fraction models that help kids conceptualize fractions. And they start with the most concrete to the most abstract. So those are great videos for multiplication, division, fractions. He's got a bunch of them. This is another example of a visual aid that's a little bit different than anything I've shared before, but I've learned, I don't know if you remember when you took math, sometimes you could take a test and you had to have everything on an index card. You bring in whatever you wanted as long as it fit on an index card. That's essentially what cue cards are. But you teach the students to write down on an index card what the things that they're struggling to remember. So if you're trying, when a student asks you, what's the difference between less than and greater than more than 3 times, you just help them make a cue card. And then through the year, they keep a ring of them handy. I've hooked them on kids' desks before. They have them in baskets. And it's kind of like a math notebook, but it's just, each card is just one thing. So like, as you're going through the unit, like the difference between the numerator and the denominator, you might make a cue card on that. And it just helps them remember it, and they're all personalized, and they learn when they need to make a cue card for themselves. So here's some other examples of someone who's struggling with like symbols to words. The names of the columns in a 4-digit number for place value. Difference between numerator and denominator. And so another good cue card is a problem solving process. A lot of kids who have struggle with executive functioning, they don't know where to start. So having sort of a script. So first you're going to read it, make it simpler, pick your strategy. So this is a little cue card that helps them on that. This is an example of making a cue card from a textbook. You can just cut out like an important thing on the textbook. Like if they can't remember the names of the columns, then you could just paste that right onto a cue card that they could use. And another strategy is color-coded procedures. So this is a partial products method for multiplication. So if you look on this side, this would all look the same to a student who might have some visual spatial difficulties. They aren't conceptually understanding that first we're multiplying the ones, then we're multiplying by tens, and here's another 10, and then here's my hundreds. So the color coding helps them really see those place value differences. It's a super simple strategy that teachers can use. You can put that up on a chart in the room to help them. And then kind of related to that would be error analysis when you take a look at their work and you can color code the patterns in their errors. That there's a whole bunch of research on giving them that specific of feedback. Another thing you could do is find common errors in your class, put one up on the screen or show it to them individually and say, help them find the error. But that's a really powerful strategy. I'm going to hurry along because I see I'm running out of time. Strategy cards is another one. When kids are struggling with basic facts, you can have them write down a strategy that helps them remember it. So it's like a precursor to memorization. They sort of unpack a strategy and then they put it on a card. So here's like, if the students, you identify from error analysis, you identify their tricky facts, and then they make themselves a card that will help them remember it. And just the act of making the card actually increases their ability to remember it. Well, this is my favorite strategy of all. When working with problem solving, we think about graphic organizers in reading, but we don't often think about them in math. But generally, there's 12 different types of structure to word problems in the elementary classroom. So this is an example of a division problem and a graphic organizer that would work for any division problem, no matter what the numbers are. So when you create a schema diagram and they know, once they say, okay, I know this is a division problem, I'm going to grab my schema diagram for division, and then they're just plugging the numbers in. It doesn't matter if they're fractions or decimals or whole numbers or hard numbers. or have a variable in there. They know it's division. So they start associating the type of problem to the schema diagram. And this is a super powerful strategy for students who struggle. And then this is really simple, but I'm really surprised at how many people do not do this. So you can always make the numbers simpler for a kid. So this is an example of, we're going to find the area of a rectangle, but look at the problems. It's 8.17 times 32.6. But if what you really want to work on is whether the kid can find the area, just take the decimals off and make it 8 times 32. So making the numbers simpler helps them still access the grade level lesson, but you're scaffolding it down to whole numbers, which makes the problem a lot easier for a lot of kids. Another big strategy is peer-assisted learning. The more you get kids talking about math in whatever level they're at, the higher their achievement's going to be. There's a lot of research on that. So whenever you teach math in such a way that you have kids talking to each other and you facilitate those conversations, those are all things that are going to shovel the ramp for all kids. So having study buddies, helping kids be peer mentors, those are all strategies that work. And this is different than having them like just be tutors. You're actually creating a lesson that helps cultivate conversation about math. I do also want to say that vocabulary is a big part of the math classroom, and students, we use a lot of words like hypotenuse or polygon in mathematics that students have never really heard. And I can't even imagine some of those words in all the languages you work with. So really making sure that you're explicitly teaching the vocabulary, the academic vocabulary for any given week of math is a really important thing that I also wanted to make sure I emphasized. So what we want to do is strategically customize instructional practices to help the students who struggle to access the knowledge in their preferred learning style and at their readiness level. So when you think about getting to know your students and that they're going to learn in one of those three modalities, kind of providing some scaffolding in their areas of weakness can help them use their areas of strength to be successful. So we do need to believe that all students can learn rigorous mathematics if we work to shovel the ramp for everybody. So I shared a whole bunch of strategies, and I'm just wondering if there is one that you might either use next week or share next week if you're not in the classroom. So our goals for today were to define math, consider the importance of a strong math foundation. I talked about the triple code model, talked about universal design of learning and 10 strategies for supporting students, and then I shared some resources for you. Do you have any questions? Color-coded math cards, visual strategies, cue cards, interactive notebooks. I love interactive notebooks. And you can just go in and search interactive notebooks and you'll get all kinds of stuff on the web.
And maybe what we could do, Dr. Cathy, is we can conclude the workshop, and then when I put the survey into the chat, usually there's some people that, as they're filling out the chat, they like to come on and ask some questions, if that works with you, Dr. Ray. And
Works for me.
yeah. Well, if you want to conclude it with the words of wisdom, and then after that we can post the survey, then we can answer some questions.
Great. As I said at the beginning, I think this topic is so important because actually the teaching of mathematics can be basic for good teaching in any subject. And understanding that, I remind us that math is like going to the gym for your brain. You go to work it out and it sharpens your mind. And then I want to conclude with this statement. Math might not teach us how to add love or subtract hate, but it does give us hope that every problem has a solution. So thank you, Dr. Cathy, for your wonderful presentation. And we hope that we have found some solutions today and that every problem in the future has a solution.
Great. Well, now I will post in the chat for those that are on Zoom or on Facebook. The chat has the survey that we need everyone to fill out. And there's a specific question. There's a couple things that people need to make sure that they have in there is that the only way that we can make sure that you attended and you paid attention is if you answer the question of 3 things that you feel like you can implement from this workshop when school starts tomorrow, for those of you that school starts on a Sunday or those that start on Monday, the first day of the week. So please make sure you add that in there. And then the last question is a question about next month's workshop. Please put a question in there for us that we can answer for the entire group in our May workshop. And so at this time, if there are any questions, please post it in the chat or raise your hand for those that are brave. So we had a lot of good content here about mathematics, and we had some excellent math teachers here today.
Someone asked a question. It wasn't really a question, it was a comment about reteaching. You need to check for understanding during the class. And I wanted to emphasize that is correct. So in the pre-teaching, reteaching strategy, some kids won't necessarily answer in the whole group. But if you pull them aside, they'll answer. So the kids who struggle tend to not be very confident. So that's what that reteaching would be. You do check for understanding in the whole class, but then you also check for understanding more in a one-on-one. And sometimes it just takes like 30 seconds. Can you tell me again how to find the area of a rectangle?
No, that's great. And it looks like Mariam has a question about games, gamification, and free sites for playing math. And I think that would be a good thing to kind of explore a little bit more about.
I saw that, and it was not something I was prepared for today because it's all changed so much since I was in the classroom. But I used to use Purple Math and coolmath.com. There is a free resource called Zern. It's not really game-like, but it does have kind of online adaptive lessons that is been pretty popular in America.
Can you spell that out?
Zern, Zearn. It's like learn with a Z.
Okay.
That's great.
And it's free.
What is the overall philosophy about gamification and mathematics?
There's a lot of research that computer-assisted instruction can help students learn skills at a individualized way. So, like Imagine Math, for example, has a math fact program. There's another one called Reflex that teachers love. But in today's world, there's no real reason for a teacher to correct math worksheets unless you are doing that error analysis and you want to see what common errors are. But a computer can teach math very well on that skills level. And then your classroom instruction could be spent on problem solving and helping kids talk about the math from real world context. So I really do, I'd say use the computer assisted instruction as much as you can so that you're freeing up your time to plan engaging problem solving lessons.
No, that's great. Should it supplement what happens in the classroom? Because I know that's going to be another question. Should computers supplement what the teacher's doing, or should it?
Definitely. I think they're designed, most of them, as supplemental. They're never meant to replace core instruction. So if you have a high quality core instructional curriculum, they generally are going to have a lot of problem solving. And then your computer adaptive system is sort of like your 20 minutes of practice. Where we used to give kids worksheets in my day, we would now assign them lessons in that computer adaptive thing, and then the computer grades it all for them. The other thing that a computer can do that I could never have done when I started teaching is it can individualize. If kids get things wrong, it drops it down. If they get it right, it increases it. So the individualization available from those supplemental programs, but your core math instruction is generally whole class problem solving, and you're doing those visual models and connecting those three representations I talked about.
Yeah, that's great. It looks like Nayan has a question about what are the best ways to make math fun?
I think when you're teaching math, I mean, my favorite way would be we start with a problem that is connected to the real world, and it makes the kids curious. And that's what we call that low floor, high ceiling. There's a great book called it's called Building Thinking Classrooms, but then he has a companion book of math tasks for the thinking classroom. And also, I'm trying to think, illustrative math has really good problems, but generally you're starting with a context, and then the kids try their own strategies on how to solve it. And then you compare the different ways kids solve it. And then you can kind of come back around and teach them visual models, and then teach them the major concepts that problem emphasizes. And when teachers are using that sort of instructional routine, they're finding a lot of success with engagement. And then in elementary grades, anytime you bring out manipulative students, engagement goes up.
That's great. Yeah, are there any other questions? Dr. Mike or Dr. Ray, do you have any questions to add?
No, I think it's been some great information. I've learned some good things as well.
Yeah.
That will help me when I'm working with teachers.
Exactly. Yeah. Well, great. Well, it looks like we have a lot of the items coming in, all the survey questions coming in. So, Dr. Beals, thank you so much for the workshop, and we'll definitely have to have you back on to focus on this important topic.
Thank you so much for giving me this opportunity. This is my first international presentation, so that was very exciting.
Well, we have people from all over, Middle East, Africa, Europe, Eastern Europe, Asia. So yeah, we're hitting a lot of different wonderful places, and we have a lot of good friends and a lot of good contacts in these places.
Well,
Yeah.
I definitely appreciate everything you all do for children across the world. That's exciting.
There is
Thank you
one
so
last question there about effectively delivering math concepts to students who struggle with English as a second language.
Yeah, that's a good question. Maybe we can end on that.
I'd say two things: the visual models, and if you look at those Graham Fletcher videos that I put in the slide deck, which I'll get out to you guys, though that's huge for students learning English as a second language. And then the second strategy is getting them to use the language they have. So giving them tasks and having them talk about how they solved it, they are using the language of math, and that actually increases their language and their comprehension at the same time. So the English ESL students can sometimes be the most silent in math class, but if they're not talking, they're probably not learning.
All right.
Yeah, that's a great answer. Awesome. Well, thank you so much, everyone. If there are any questions at any time about how Array Global can help you, please reach out to us. You have our email addresses. The certificates will be sent out Wednesday morning for you. And so please look in your email for that, and keep in touch with us if there's any questions or any way that we can help. And we look forward to seeing you at our next workshop. Thank you again, Dr. Beals, Dr. Poe.
Thank you.
Yep. Take care.
And I'll put the slides in that folder I shared, so they should get it that way.
Okay. Sounds good. Thank you.
Thank you.
Yep. Bye.